Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the video lecture series on analog filter in IIR filter design. First, what is mean by IIR systems? Length of the unit sample response or impulse response H of n is infinite. What is mean by IIR filter? The filter is designed by considering all the infinite samples of impulse response is called as IIR filter. In the design of IIR filter, the specifications of IIR filter is transformed to specification of the analog filter and then analog filter with transfer function. H of S is designed to satisfy the specification, then the analog filter is transformed to digital filter with transfer function H of Z. Next one, we can see the advantages and disadvantages. The value of resistor, capacitor and inductor used in analog filter changes with temperature. Since the digital filter does not have these components, they have high thermal stability. The digital filters are programmable. The filter coefficients can be changed at any time to implement adaptive filters. The single filter can be used to process multiple signals by the terms using a technique called multiplexing. In digital filters, the precision of the filter depends upon the length of the register used to store the coefficients. Next one, disadvantages. The bandwidth of the discrete time signal is limited by the sampling frequency. The bandwidth of the real time discrete signal is half of the sampling frequency. The performance of the digital filter depends only on hardware used to implement the filter. Then features. The physically realizable IIR filter does not have linear phase. The IIR filter specifications include the desired characteristics for the magnitude response only. Next one, we can see the comparison of digital filter and analog filter. Digital filter, it operates on digital samples of the signal. Analog filter operates on analog signals. Digital filter governed by linear difference equation. Analog filter is governed by linear differential equation. Digital filter consists of adders, multipliers and delay to implement the digital logic. Analog filter consists of electrical components like resistor, capacitor and inductors. In digital filter, the filter coefficients designed to satisfy the desired frequency response. In analog filter, the approximation problem is solved to satisfy the desired frequency response. Next one, we can see the filters or frequency selective devices. So they are used to design to pass the spectral content of the input signal in a specified band of frequencies. Hence, based on the frequency response of the filters are classified into four types. They are low pass, high pass, band pass and band stop. Now we can see the frequency response. The approximation problem is solved to meet the desired specified tolerance in the pass band and stop band. In the pass band, the magnitude is approximated to unity with an error of del of p. In the stop band, the magnitude is approximated with 0 with an error of del of s. Here, del of p, del of f are the limits of the tolerance in the pass band and stop band. The del of p and del of f are also called as ripples. Next, this is the specification of the practical analog filter and digital IIR filter. Ohm P, pass band edge frequency in radians per second. Ohm S, stop band edge frequency in radians per second. AP, gain at pass band edge frequency. AS, gain at stop band edge frequency. Omega P, pass band edge frequency in radians per sample. Omega S, stop band edge frequency in radians per sample. AP, gain at pass band edge frequency. AS, gain at stop band edge frequency. This is the normalized IIR magnitude response of ideal analog low pass filter and practical analog low pass filter. This is the pass band only. We can pass the low frequencies and stop the remaining frequencies. This is the practical analog filter with respect to transition band. Next one, similarly for high pass filter, first we can stop the low frequencies and only we can pass the high frequencies. That's why the practical analog filter is shown with respect to transition band. This is the ideal analog band pass filter. Only we can pass only the frequencies. Band pass filter means only we can pass the frequencies. Remaining all other we can stop. For practical analog band pass filter as shown with respect to transition band. Next one, band stop filter. Only we can high frequencies you can pass and low frequencies we can stop. That's why it's called as your band stop filter. The practical analog band stop filter can be shown with respect to transition band. Now we can see there are two techniques involved in analog filter, IIR filter design, that is impulse invariant transformation and bilinear transformation. See, impulse invariant transformation is the objective of impulse invariant transformation is to develop an IIR filter transfer function whose impulse response is the sampled version of the impulse response of the analog filter. Transfer function of analog filter H of s is equal to Laplace transform of H of t. T is nothing but your sampling period. Therefore, we can get it as your 1 by s plus p of k can be defined as 1 divided by 1 minus e power minus pk into t into z inverse. The relation between analog and digital frequency is digital frequency omega is equal to ohm t, analog frequency ohm is equal to omega by t. Next one, this is the impulse invariant transformation from S plane to Z plane. S plane means it can be represented in terms of left half plane and right half plane that can be converted into your unit circle in the Z plane. Next one, we can see the bilinear transformation. Bilinear transformation is the conformal mapping that transforms imaginary axis in the S plane to the unit circle in the Z plane to avoid aliasing of frequency components. In this mapping, all points in the left half of S plane are mapped into inside the unit circle in the Z plane, and all the points of the right half of the S plane are mapped into the outside of the unit circle in the Z plane. It is a one-to-one mapping. T is nothing but sampling time period. S can be defined as 2 by T into 1 minus Z inverse divided by 1 plus Z inverse. This is the S plane to Z plane, left half plane, right half plane. The left half plane can be mapped into here inside the unit circle of the Z plane. The right half plane can be mapped into here outside of the unit circle in the Z plane. Next one, this is the relationship between analog and digital frequencies. Analog frequency ohm is equal to 2 by t into tan of omega by 2. Digital frequency omega is equal to 2 tan inverse of ohm t by 2. In bilinear transformation, the relationship between the analog and digital frequencies is non-linear. When the S plane is mapped into Z plane using bilinear transformation, this non-linear relationship introduces distortion in frequency axis, which is called as frequency warping. In IIR filter design using bilinear transformation, the conversion of specified digital frequencies to analog frequencies is called as pre-warping. How to eliminate this pre-warping means the pre-warping is to eliminate the effect of warping of the amplitude response. But this is the pre-warping with respect to omega and ohm t, 2 tan inverse of ohm t by 2. We can by using bilinear transformation. Warping omega is equal to ohm t means that is impulse invariant transformation. Now we can see the assessment. Define IIR systems. The system which is considering only the infinite samples of impulse response is called as IIR systems. Mention the advantages and disadvantages of IIR filter. Advantages means the single filter can be used to process multiple signals by using the filter. Disadvantages means the performance of the digital filter depends only on hardware to design the filter. The del of P and del of F are also called as ripples. Compare analog filter and digital filter. Digital filter operates on digital frequencies. Analog filter operates on analog signals. Digital filter is governed by linear difference equation. Analog filter is governed by linear differential equation. Based on the frequency response, the filters are classified into 4 basic types. They are low pass, high pass, band pass and band stop. Define bilinear transformation. Bilinear transformation is a conformal mapping that maps the imaginary axis of the S plane is mapped into the unit circle in the Z plane. It is a one-to-one mapping. What is S can be defined as 2 by t into 1 minus Z inverse divided by 1 plus 2 is Z inverse. What is mean by pre-warping? In IIR filter design using bilinear transformation, the digital frequencies can be converted into analog frequencies is called as pre-warping. Thank you.